Okay guys, I'm in the back of the classroom. I've been having serious technical difficulties, so I'm actually changing which computer I'm using. I don't have a calculator on this one, so hopefully it works out. You're kind of going to just have to take my word for a few things, but let's see. So this one, it's asking us to do some graphing. So it says to graph this and find the real solutions to this. So I know that these are going to be roots because I'm seeing when it's equal to 0, and then I have to verify it algebraically. So I pulled up my calculator in the back here, and I went ahead and I found when it was equal to 0. So I am going to go ahead. I unplugged my computer. I'll plug this back in here. Sorry, my face is everywhere here, probably. Okay. So let's see. No, let's graph this thing. So the points that I need, asking me this question. The points that I need are, well, the first one is -2, -8. It's the first point I can graph. So -2, -1, 2, 3, 4, 5, 6, 7, -8 is right there. Then I have -1, -3, -1, -3. I have 0, -4, and 2, 0. And then the next point is all the way up at 317, so that would be off the graph, which means my graph must be doing something like this. It's kind of interesting, right? Something like that. So the real solution is going to be x equals 2. There is my real solution to that equation. It's right here. Then I need to verify algebraically that it is a 0, so it says write f of x is the product of a linear factor and a quadratic factor. Interesting. Okay. So right now I've got x to the third minus 2x minus 4 equals 0. So whenever I am doing something like this, I want to find it as a quadratic and a linear factor. Well, I gotta find what I might have been multiplying. So some x squared term times some x term. I'm gonna have to think this through. I'll be right back. Okay, so it took me a moment, and then I realized the key is this. The fact that my factor is 2, that means I need to have a root right there. That is x minus 2, right? Because the factor is 2, the root has to be x minus 2. So then I know that this is divisible by x minus 2. So if I do long division, I can find the other factor. So I'm going to do this problem lower down. This can still work for this. So I'm going to do x to the third power. I'm going to say plus 0x squared minus 2x minus 4. And I want to see if x minus 2 goes in evenly, which it will, and then figure out what's going to be left. So x goes into x to the third, x squared times. So I'm going to put an x squared as my first factor. And then I multiply. X squared times x is x to the third. X squared times -2 is -2x squared. I subtract, those cancel. 0 minus -2x squared is 2x squared. Bring down -2x. I don't know why it does that sometimes. Undo. Bring down the x. Okay. X squared is my first factor. Okay, now x goes into 2x squared 2x times, so plus 2x. Then I distribute. X times 2x is 2x squared. 2x times -2 is -4x. Subtract. Cancels. -2 minus -4 is like -2 plus 4, which is 2x. Bring down the -4. Okay, x goes into 2x 2 times. So 2 times x is 2x. 2 times -2 is -4. And hey, those both cancel, so there's no remainder, which means that I can write this as x minus 2 times x squared plus 2x plus 2. Pretty cool. And so now I need to find the complex solutions. So to find the complex solutions, I'm going to take this and complete the square. So x squared plus 2x equals -2. Complete the square, divide by 2 and square. I get 1 plus 1. This factors to x plus 1 squared equals, and I don't know why it's just doing these weird selections over here. I don't want this selected. So x plus 1 squared equals Negative 2 plus 1 is negative 1. Square root both sides. So I get x plus 1 equals positive and negative square root of 1 is I. Minus 1, minus 1. I get x equals negative 1 plus or minus I. Those are my complex solutions. That was cool. I like that problem. Alright. This point is on the unit circle. What Pythagorean triple is associated with the point? And use the equation of the circle to prove that this is the point on the circle. So, first of all, I've got my unit circle in one point right here. The x-coordinate is 8, 17. So 8, 17 is the x. The y is 15, 17. So that means that my x-coordinate would go here on this right triangle I'm drawing. So that would be 8, 17. And this would be 15, 17. So I know that this is an 8, 15. Oh gosh, I need to check this. Let's see. 8 squared plus 15 squared equals c squared. 64 plus 15 squared. God, I'm going to have to do it on the calculator off to the side. I'm doing it now. Let's see. 15 squared. 15 times 15. I want to say it's 225. Let's see. Squared. 225 yet? 225 equals c squared. 64 plus 225 is going to be, I really am embarrassed, I'm using a calculator for this, 289. Square root, I feel like it's going to be like, yep, it's 17 squared. C equals 17. So this over here would be 17 over 17. So this is a 8, 15, 17 triple. Okay. Next up. Where are we going? Use the equation of the circle to prove that this is a point on the circle. So I can say 8, 17 squared plus the y-coordinate, which is 15, 17 squared, equals 1. And then I just need to make sure that this works out. So this would become 64 over 17 squared, which is 289, plus 15 squared, which would be 225, over 17 squared, which is 289, equals 1. So when I add 64 and 225, I get 289 over 289, which equals 1, which is true. So the point is on the circle. All right. Jessica started a new bracelet company. Her monthly profit was in hundreds of dollars, and it can be modeled using this function. Graph it, provided using the domain from 1 all the way up to 12. Interesting. In what month did she make the most money? Okay, so this is the part where you're going to have to take me a bit for my word, because I'm going to do it on my calculator off to the side. So if I pull up my calculator over here and I graph it, oh, you don't need to see me do this. I'm going to pause it. Okay. So I'm going to graph it now. So I've got the point 0, negative 120. Point right there. Then I have 1, negative 45. Then I have 2, 0. I have 321. I have 424. 515. 6, 0. 7, I gotta scroll down on my calculator now to see this. 7 is negative 15. Oh, poor Jessica, looks like she's losing money. 8 is negative 24. 9 is negative 21. 10 is 0. 11 is going to be 45. 12 is 120. 13 is 231. Oh, well, I guess it's off there. I've graphed from 0 to 12, so I'm good. So during what month did she make the most money? Well, she made the most money during month 12. During what month did her profit decrease? Months did it decrease? So it started decreasing from month 4. So I'll say from 4 to, and then it stopped decreasing in month 8. Do you think that g of x will model her profits over the next year when x is an integer such that it's between 13 and 24? Well, if I take a look at this graph, I think it's going to approach infinity. So definitely, I'm going to go with no. And I'm going to say when x equals 24, y equals 5,544. I just checked my calculators. This is too high. And that's because, right, this graph is going to be approaching infinity as it gets higher on that end. Okay. And I believe that's it. Yes, it is. All right, I hope it went really well for everybody. That's the end of this video key. I will upload it all separately.